welcome also from my side. I'm Lukas Kranzl, Senior Scientist at TU Wien, Technical University in Vienna, and I will present some attributes of transformative electrification pathways from the sectoral demand perspective. So I will structure my presentation along these key messages. First, electrification is a key measure in all demand sectors. We heard a lot about electrification as such, but I would like to show that it's also relevant for all the different demand sectors. Second, it requires a ramp up of new equipment, which is in some sectors and for some technologies above the recent pace, but for some technologies and for some sectors also in line with what we already saw in the past few years. Third, electrification shouldn't be understood as a standalone measure, but needs to be embedded in holistic efficiency packages. And in that sense, electrification both facilitates, but also requires the exploitation of efficiency potential, in particular for transport and buildings. We also dealt a lot with, or at least a bit with behavioral questions and how lifestyle changes could affect demand. Also the question how circular economy measures could affect demand. And as one example, I will show that circular building construction also reduces the industrial final energy demand. All that needs a lot of policy, stringent policy framework, which partly is already in place, which partly, but also still needs to be implemented in a stringent way on national level and needs to be further enforced. Coming to my first point, electrification, a key measures in all demand sectors. So I will show also in the next slides always the results by the separated by the sectors transport, buildings and industry. Here we see the share of electricity on total final energy demand. The blue ranges show the result of the full system models, as also already presented by Robert before, and the green range is the sectoral models, which focus on a higher granularity on some specific technological and sectoral specific elements. So we first see that in general, the trend in these two groups of model types is similar. For transport, we see the fastest increase that will be needed. It means, and that's a robust result across the models and the scenarios, that passenger cars are almost fully electrified by towards the end of the period. But there are model differences and also scenario differences in heavy-duty vehicles, where partly hydrogen could also play a role. In the building sector, we see, of course, a high relevance of heat pumps taking up, but it's also important to understand that we are not starting from zero, which on the one hand is because of electric appliances in the building sector, of course, but also at least in some countries, not insignificant part of heat demand is also electrified already, but via inefficient direct resistance heaters. So electrification in that sense also means to improve the use, how we use electricity and increase the efficiency. Third, the industry sector. Here we also see that electrification is relevant to all subsectors. We see in all the sectors doubling of the electricity share, and with some subsectors also achieving ranges of 85% of electricity. Hydrogen was already mentioned before, that it's key for some industry branches, for some processes. The results show that it's rather a supplement, rarely a substitute to electrification in the industry. Second message, this requires a quite ambitious ramp up of new equipment. Coming to transport, of course, electric vehicle registrations would need to quite significantly increase. That also depends on or will require additional technological development. to increase the electric vehicle range and to also at the same time reduce range anxiety of consumers. Battery cost reduction is important. We already can expect that for some size segments we achieve cost parity very soon, and for low to medium range vehicles, probably this cost parity will be achieved by 2030. For the building sector, of course, also this quite strong increase of heat pump installations is expected. So up to 3 to 5-fold. Most scenarios are in this range of 3 to 5-fold increase of heat pump installations by 2040. This sounds a lot, and yeah, it is a lot, but at the same time, we also see that the speed of required heat pump uptake is in line with what we've seen in the last 10 years, and that in particular in the first years of this decade, the installation was actually higher than what we would have seen in the most ambitious scenarios here. For the industry sector, again, the main point is actually electrification of process heat generation. So the process heat supply would be based on electric furnaces, boilers, heat pumps, partly also boilers and heat pumps combined, depending on the temperature level required in the specific process. In general, across all sectors, we see that this will need to increase by a factor 8 to 12 from now until 2040 to 50. Next point, electrification on the one hand facilitates, but on the other hand also requires exploitation of efficiency potentials. When we look at the total final energy demand, we see quite significant energy savings that electrification can achieve. So a lot of these savings and reduced energy demand that we see in the transport sector comes from this electrification of road transports. But at the same time, that's not the whole story. There are also a lot of other measures, such as modal shifts, which are part of the story, both for passenger and freight transport. In the building sector, I think it's quite clear that heat pump installation only is one part of the whole package of efficiency measures. So building renovation, improving the building envelope, and increasing the energy performance of buildings in a holistic way is essential. So electrification needs to be embedded in these holistic and deep renovation packages. And if that's being done, then we also see a high synergy between building retrofitting and the heat pump uptake, leading then to a potentially quite significant reduction of final energy demand in the range of 40 to 50%. On the industry side, we see that energy efficiency can save, in particular, high-value energy carriers, but the models also differ in the estimated saving potential, in particular when it comes to electricity. As I said, we also had a closer look on the question, how can lifestyle changes, behavioral changes affect energy demand, and also how can circularity and circular economy-related measures affect final energy demand. And in this study, we had a look at how circularity measures related to buildings, such as reusing and recycling of materials, material substitution, material efficient design, can affect the final energy demand, in particular of iron and steel sector, which is here shown here on the left-hand side in this graph. And the result is that, yes, circularity measures in buildings can strongly reduce the final industrial energy demand, in particular in the steel industry. But there are also quite significant uncertainties regarding the quantified contributions because of different production technology assumptions, different recycling rates, recycling potentials. And it also turned out that circular economy measures are not just tiny improvements of efficiency in some process, but rather require fundamental changes in production and consumption. All that will not come from alone. It needs a consistent and policy set. A lot of these policies are already in place, have been put into the European policy framework in the past few years. At the same time, an ambitious implementation on the countryside partly is still missing, and also they need to be maintained and partly also further strengthened. So we see, for example, as a regulatory measure, high CO2 standards in the transport sector play a big role. ICE ban. On the building sector, we implemented what the minimum energy performance standards, which are part of the European Performance of Buildings Directive. But we implemented both for residential and non-residential buildings. In the EPBD, they're mandatory only for non-residential buildings. On the industry side, one of these regulatory measures also to have obligations for retiring of last remaining fossil installations. Economic measures are more or less similar: CO2 pricing, subsidies for technology, infrastructure. And then regarding infrastructure-related and behavioral-related policies, there are a lot of measures such as incentivizing sharing economy to increase the occupancy factor in transport, also to bring forward modal shifts. On the building side, we have a lot of measures such as renovation passports, one-stop shops for building renovation, improved energy performance certificates. All that should and is expected to lead to accelerated replacement of fossil heating system, accelerated building renovation, and improved technology acceptance. So with that, I come back to my key messages that I already presented in the beginning, and looking forward to the discussion.